Today we are going to look at solving absolute value equations. So before we go too far into how to solve these equations, we need to review a little bit about absolute value. From middle school, hopefully you remember that the absolute value of a number is its distance from zero on a number line. So what's important to understand is that when we're talking about distance, it can never be negative. So when I travel in my car, even if I go in reverse, I still am gaining more miles. So I still am going a positive number of miles. So absolute value can never be negative. So when we look at something like this here, these bars indicate absolute value. So this is saying the absolute value of x equals 3. So my distance from 0 on the number line is 3. Well, if I start at 0 and I go 3 spaces, it has not told me direction. So I can go 3 steps to the right, which puts me at positive 3. But I could also go 3 steps to the left, which puts me at negative 3. So on a lot of these absolute value problems, you are going to see 2 answers. Now, down here, we see this. The absolute value of x equals negative 5. So this is saying the distance from 0 on the number line is negative 5 steps. We cannot go a negative number of steps. So this cannot be done. We say that this is undefined or has no solution. So if we look at our first question here, this says the absolute value of t minus 7 equals 4. When you are solving an absolute value equation, you always need to isolate or get the absolute value by itself first. So in this case, that means I want to get this here by itself before we do anything else. So it is on the left-hand side of the equal sign along with negative 7. So to get rid of negative 7, the opposite of minus 7 is plus 7. So I am going to add 7 on both sides. When I do that, these 7s are going to cancel each other out. So I am able to say that the absolute value of t is equal to 4 plus 7 is 11. Now, at this point, what you are going to do to get those 2 answers, because remember we can go left or right on the number line, to get those 2 answers, we are going to split this into 2 separate equations. So for your first equation, all that you are going to do is get rid of the absolute value bars. Otherwise, you're going to write everything the same. So we will write t equals 11. For your second equation, you are going to get rid of the absolute value bars, but you are going to change whatever is on the other side to a negative. So t equals negative 11. In this case, both of these equations don't have anything else for us to do in terms of solving, so these are our answers. If we move to the next example, on this one, I see my absolute value bars are again on the left-hand side, but unlike the last one, everything on the left-hand side is inside of the absolute value bars. So on this one, my very first step is to go ahead and split this into 2 equations. So again, for that first equation, you are going to leave everything the same, just get rid of your absolute value bars. So we will have 2p plus 5 equals 11. And for your second equation, you're going to get rid of the absolute value bars and then change the number on the other side to a negative. So we will have 2p plus 5 equals negative 11. So now I need to solve each of these equations just like we've been solving in the rest of chapter 2. So here's my wall through my equal sign. I always remove anything held on by addition or subtraction first. So I'm going to subtract 5 from both sides Those 5s are going to cancel out, leaving me with 2p on the left-hand side, and that's going to be equal to 11 minus 5 is 6. And then to finish solving, I'm going to divide both sides by 2. When I divide by 2, these 2's on the left-hand side will cancel, and 6 divided by 2 is 3. So for my first answer, I can say that P is equal to 3. Now to get my second answer here, I have to solve the purple equation. Same way though, just following my normal rules for solving equations that we've learned in Chapter 2. So I first need to get rid of the 5 because it's held on by addition. So I'm going to subtract 5 on both sides. So when I subtract 5's, these will cancel. So I can say that 2p is equal to negative 11 minus 5 is going to give us negative 16. And then I need to divide both sides by 2. When I divide by 2 on the left-hand side, these cancel, leaving me with just p. And negative 16 divided by 2 gives us negative 8. So this is our other answer. Moving to your next example, we have this. It says, is there a solution of absolute value of 10 plus 5y equals negative 8? So remember, absolute value represents a distance. So this is me saying the distance from 0 is negative 8. So really what I'm asking here is, can we go negative 8 steps away from 0 on the number line? Hopefully your thought process there told you no. And your reason for that, your reason that you cannot make that happen is because distance can't be negative. So what you need to think through there is I can't travel a negative number of miles, I can't travel a negative number of feet, I can't go a negative number of steps on the number line. So absolute value cannot equal a negative number. If we look at this example here, I see that my absolute value bars are on the left-hand side, but again, we're back to a situation where we have extra things outside of the absolute value bars, but on the same side of the equation or on the same side of the wall. Those items have to be moved first before we can separate this into two equations. So I'm going to move anything held on by addition or subtraction first. So I'm going to start by subtracting 13 on both sides. So when I subtract 13, these are going to cancel, which allows me to say that 8 times the absolute value of 3x is equal to 37 minus 13 is 24. But still over here on the left-hand side, the absolute value is not by itself. I still have this 8 that's outside. Since the 8 is being smashed against the absolute value bar, that means it's being multiplied on. The opposite of multiplication is division. So I'm going to need to divide both sides by 8. So when I do that, these will cancel, allowing me to say that the absolute value of 3x is equal to 3. 24 divided by 8 is 3. And now I finally have the absolute value bars by themselves. So now that the only thing on the left-hand side are the absolute value bars and what are inside of them, now we can separate this into two separate equations. So we're going to break this into two. For the first equation, the only thing that you're going to do is get rid of your absolute value bars. So we're going to write this as 3x equals 3. For the second equation, you are going to get rid of the bars and change the number on the other side of the equation to a negative. So 3x equals negative 3. So to solve the purple equation, I simply have to divide both sides by 3. So the 3's on the left-hand side are going to cancel out to leave me with just x, which was my goal. And then 3 divided by 3 would give us 1. So x equals 1. That's one of our solutions. For the green equation, I'm going to need to do the same thing. To get rid of this 3, I'm going to need to divide by 3. And when I divide by 3, these will cancel. And negative 3 divided by 3 would be negative 1. So x equals negative 1. Okay. One final example here to work through. Again, in this one, we have some extra pieces on the left-hand side with the absolute value bars to start. So I need to remove those first. Remove anything held onto the bars by addition or subtraction first. So that's going to be this plus 10. So I'm going to start by subtracting 10 from both sides. So when I subtract 10, these are going to cancel out. That allows me to say that negative 2 times the absolute value of x minus 13 equals negative 22 minus 10 would be negative 32. And then I still have this negative here to get rid of. Again, this is a multiplication situation, so I need to divide by negative 2 on both sides. So on the left-hand side, these negatives are going to cancel. And on the right-hand side, I have a negative divided by a negative, which becomes a positive. And 32 divided by 2 is going to give us 16. So this is what we're working with. It's not until this step that you can decide if you have a no solution problem or not. You cannot decide until the absolute value is by itself. So I need to separate this into two equations. So for the first one, remember all I do is get rid of the bars. So x minus 13 equals 16. And for the second equation, I get rid of the bars and change the number on the other side to a negative. So x minus 13 equals negative 16. So going back to the blue equation, this requires only one step to solve. To get rid of this minus 13, I'm going to add 13 to both sides. So the 13's on the left will cancel out. And 16 plus 13 gives us 29. So x equals 29 is one of our answers. In the purple equation, to get x by itself, again, I'm going to need to add 13 to both sides. And add 13 here. The 13's on the left are going to cancel out. And negative 16 plus 13 is going to leave me with negative 3. So this is your second answer.